Hi, I'm Amit Dawadi with a YouTube video series on electrodynamics. In this series, I'll be solving problems from fundamental to standard level, covering all concepts of David J Griffith. It is a standard undergraduate course book on electrodynamics. Please like and subscribe this channel if you want fresh videos covering various parts of the physics. Uh, I'll be uploading recently the uh, problem sets of problem and solution of the electrodynamics as well. So let's start our today's discussion with the very first problem set on the electrodynamics on electric charge, forces, energy stored in charge, configuration, electric field. Before entering to this part, let's shortly revise the basic theory involving the electric forces and the electric field between two charges. Well, so I have two charges, Q1 and Q2. Let's say the charges are Q1 and Q2. Q1 is here. Uh, let's say this is Q1, this is Q2, and uh, the force is given by the magnitude of the force is given by the Coulomb law, which is this formula. And here the very important part is what is this R12 and what is this R12 cap. So this Q1 and Q2 gives is the magnitude of the charges including their sign, and K is 1 by 4 pi epsilon naught, where epsilon naught is the permittivity of free space. Then this R12 is the distance between these two charges. Suppose, yeah, this R12 is the distance between two charges, point charges and the source charges, the destination point and the source point. And this direction of the force is always you have to take from the charge 2 to the charge 1, charge 2 to the charge 1, or from the source charge to the point charge which is experiencing force. So let's begin our the problem. Okay, well, I have three charges. Plus q charge is on top, sorry, minus 2q charge is on top, and the plus 2q charge at the bottom. Now I'm interested in finding the electric force at charge q because of these two charge configurations. So let's begin with that. So I will draw my the axis something like this. I have the y-axis along that direction. Let me call this as the z vector. I have two charges, minus 2q charge, and here plus 2q charge lies L distance far away from the charge q, and I'm interested in finding the electric field, also electric force experienced by this charge. So this charge experience force because of these both charges. So we calculate the electric field, the electric force at the middle charge because of the top charge. Similarly, we calculate the electric field at the middle charge because of the bottom charge, and we add them to get the net force on the middle charge by the vector sum. So to begin with, force at middle charge because of the top charge, remember once the formula, force between two charges as we saw before is q1 into q2 divided by r12 square into r12 cap. This, the direction of the force is always, we have to mention from the source charge to the charge which experiences force because of that charge. So in this case we are going to find the field at this point, right? So our source charge would be this. we are going to calculate the electric force at this point. So the electric force at the middle because of the top is K, Q1 into Q2, or Q1 is the source charge to Q, Q2 is the destination charge which experiences the forces Q, divided by distance between them is square is L square, and the direction is from R1 to first charge to second charge, or from the source charge to the charge which experiences the force. Here our source charge is minus 2q. We are interested in finding the force at this point. So direction would be something like this. So I write minus j. So in total, if I look here, the important part is you didn't have to forget this. So this goes, and I get k to q square by L square. This is because of the top plate, and which is acting in total towards the up. So the force experienced by the charge q because of the top charge minus 2q is along positive y direction. Now let's calculate the force on the charge q, or let's say this as our usual notation, force on the middle charge due to the bottom charge, which is k into source charge is 2q, and the charge which experience force is q, divided by distance between them is L square, and the direction is always from the source charge to the destination charge. Our source charge is 2q, so it is pointing upward, so its direction is plus j, right, plus j. Now we have both expressions. Okay, let me write this as 2q square k by L square plus z. Okay, so now the F net is the net force experienced by the middle charge, is the force experienced by middle charge because of the top charge plus force experienced by the middle charge because of the bottom charge, which goes something like k 2q square by L square along z direction, g direction, positive j direction, plus k 2q square by L square also on the plus g direction. This gives me k times 4q square by L square and z direction. So the middle charge, and if you can look here, so the middle charge experience force towards the positive y direction because of this charge setup on the system. Now let's look on the second type of problem. In this case, we have the charge distribution on the xy plane. We have 3-point charges, and we are interested to find the force on this charge plus 2q because of these two charges. One is at the origin and one is at the on the x-axis at 3q. So let's start this one. Let me draw the figure at first. I have two charges. Here one charge it at the origin, which is negative q, and next is 3q at 3l distance away from the origin. Now we are interested in finding the force at charge positive 2q, which is lies at the coordinate L to L. So let's recall once the formula for the force at any point is k equals to, force on any point charge is k, F equals to k times charge, total charge of that point charge, multiplied by the source charge, let's say q1 q2, divided by r12. Sorry, this is not the vector, let me make it clear. It is just the magnitude. All right, and the direction is always from source charge to the the destination charge. So let us calculate the force on the charge 2q due to minus q charge, which is equal to the k times q1 is our source charge is minus q, destination charge is 2q because we are interested in finding the force at that point, divided by the distance. Distance is this distance, magnitude of this distance you can get by, since this is 90 degree, you can get by the Pythagoras relation to L square plus L square. This gives me L root under 5, or let me make it clear. The distance is root under 5 L square whole square, and the direction is from this to here. Or before that, I think it would be better to calculate the now let me do this once. Let me calculate the r12 vector before proceeding further. R12 vector is from R12 vector for this, let me call, okay, I think okay, better let me give the name of these 3 points. This I give origin O, this is point A and this is point B. Then I write position vector of the destination point as from 1 to that point is it is L 2L I vector plus, suppose this is x-axis and this is y-axis, x and y-axis. So this is x-axis and that is y-axis. So 2L I vector x and L z vector. So I write its modulus as root under 2L squared plus L squared equals to root under 5L squared, or L root under 5. So the force on charge at A because of O is equals to the K times the source charge is minus Q, destination charge is 2Q, divided by distance between them is this, so its square is 5L square, and the direction is given by this vector. So better I would write, let me just make you clear that this formula I can write as this formula I can write also as kq1 q2 by r12 whole cube r12 r vector. I am changing this unit vector to the full vector and I am just increasing the magnitude by a factor of the 1. So here I would write okay, the force at charge at A because of O is equal to K minus Q into 2Q, divided by distance between them is L root under 5 whole cube, into the direction is given by this vector OA. R12 vector is ROA vector. ROA vector is 2L I vector plus L G vector. This is first expression. Similarly, for the second charge, if we look on this, the distance between this charge and this charge this is r13. This can be calculated by calculating the vector from A to B. So let me do that. I want the vector from point charge to the destination charge. This vector, this would be the direction of the force. So I calculate the BA vector. First of all, BA vector is equal to OA vector minus OB vector. OA vector, as you can see from here, is 2Li plus Lj, is 2Li plus Lg minus OB is this one. Its y component is 0, so the x component is 3L minus 3Li, which gives me minus Li plus Lg. So it's okay, r vector is equal to, its magnitude is root under L square plus L square equal to at root under 2. So force at the charge at A because of the charge on B is equals to the K times the source charge here 3Q, the destination charge 2Q, divided by the magnitude cube. Magnitude cube is L root under 2 whole cube into the direction. Direction is given by this vector minus Li plus Lg. Now we have two expressions because of the two charges. Now we calculate the net charges as we did before. The net charges, the net forces. Net force on the charge, let me calculate the net force on the charge, F net, I'm sorry, this, okay, F net equals to, okay, force at A because of the charge at origin plus force at A because of the charge at B. Now the force on A because of the charge at O is, you can get from here, it is minus 2Q square K by, it is minus 2Q square K by, distance between them is L root under 5. This I can write L cube into 5 root under 5, and the direction is 2Li plus Lg. And because of the force on the A because of the B is this, so I will just copy this expression, and I would paste it here. Let me bring this down. Okay, this is my expression for the, yeah, let me change the color of this part if it allows me to change. Okay, by the way, okay, so yeah, so I have written here the force because of the first charge is in the green color, and the force because of the second charge is on the red color. Okay, so this first expression, as you can see here, this first expression is the force, I'm sorry, the the force on the charge at A because of the charge and origin, and this force, this part is the force on the charge at A because of the charge on B. So if I add this total, I would get, okay, I need to remove this part. Where is the, okay, so in total I can add the x component and the y component separately. If I add x component, here is the minus L and here is the 2L. If I add these two, I can have the common of this part. You can look on the 2q squared by, okay, let me just separate this part. So I would get minus 2q squared k by L cube 5 root under 5 plus, I'm sorry, 6k squared by L squared 2 root under 2, right, and the common is, let me change the sign here. I get minus, and here it is 2 comes and it goes is 4, so this goes like along the I direction, and from the last two part I can have same expression as this, I can have the same expression right here, but along the y direction, L into G direction. Okay, so yeah, but the sign would be here positive because of this sign. So this is my final expression of the force. You can just do the simple mathematics and get the final expression of this relation. So yeah, I discussed today only on these two problems. So basically, while calculating the force on the charge, Q1 because of charge Q2, sorry, if you want to calculate the force on this charge, if you want to calculate on the force charge because of this charge, this is the source charge, it emits electric field from here, and because of this electric field, this charge experiences the force. If you want to calculate that force, you always have to take the direction away from the first charge, right? So the force on the charge Q2 because of Q1 is equal to, always you have to take care of the distance and the direction. Direction is always away from the point charge. How we calculate is K, source charge, the destination charge where you want to find the electric force, divided by the magnitude of the distance between them, and the direction is always from first charge to second charge. This would give you the proper expression. And if you have more than 1 point charges, then you get the force on net force on the destination charges, the vector sum of all forces because of the remaining charges on